Hello everyone. In this video we are going to see how can we deploy a Docker image in AWS Lambda containers. Quite interesting topic, right? Let's get started. So first, what are we going to cover in this video? We'll see how can we deploy a simple machine learning model in AWS Lambda containers instead of deploying a simple hello world addition subtraction. We'll just try in a different way. We'll deploy a machine learning model here. Also, we are going to see how can we deploy an existing Flask Docker image, right? When you talk about AWS Lambda containers, technically speaking, we cannot deploy a Flask, Docker images. We need to do a few tweaks. There is a workaround, which we are going to see how can we, use those workarounds to deploying a Flask Docker image. And the other one, how can we build a Docker image for x86 64-bit and ARM64? These are the two different types of a CPU architecture that AWS Lambda provides. You talk a typical AWS Lambda or Lambda in containers. In both the option, this particular CPU architecture is provided by Lambda. So we are going to see how can we build accordingly. And first, what are the advantages of going to Lambda containers than the traditional Lambda itself, right? First of all, if you see a traditional Lambda, it supports up to 250 MB of packaging, very less, right? If you go with containers, you can go up to 10 GB, right? So that is one of the very big improvement if you go with the containers, right? Where is 250 MB and where is 10 GB, right? So this helps to deploy machine learning models and a complex data pre-processing logic where you need some Python packages that can go beyond 250 MB, right? But again, there's a catch that this particular Lambda containers can run for 15 minutes because that's a default timeout for Lambda, and we can go maximum up to 15 GB RAM. So with these two conditions, yes. In case if these two condition matches, then yeah, it's one of the best choice I can say. And we can also see, as I said, x86 architecture versus ARM64, right? So I'll talk quickly about it in terms of price. If you go with x86 64, it's a default Lambda price, but if you go with ARM 64-bit CPU architecture, it will be a little bit cheaper than x86 64 architecture. In case if you're thinking about large scale application or long running workloads, I would typically prefer for ARM because for longer running and large scale application, this in terms of cost, this definitely benefits. But if you are looking for a complex data pre-processing where the CPU power matters, in that case, you can go with x86 and 64-bit architecture. Okay, so let's jump into the demo now. Let me, I'll quickly show what the ML model we are deploying. It's a simple iris dataset. Iris dataset is kind of a hello world application, for the data scientists and machine learning enthusiasts, right? So we are using scikit-learn package here to train the model. We are using logistic, k-nearest, SNP. We are not discussing those, but yes, we are using an iris dataset to train a model, right? I'll upload this the Jupyter notebook in the Git repo, and I'll keep that in the description. In case if you want to try, you just download this and build an image. I mean, not image, I'm sorry, like a model. So here if you see, I'm exporting a trained model which is built using logistic regression, right? Using a joblib, I'm just exporting it, and it is actually this trained model is saved. Yeah, here, did you see? Right, and I'll also show you a simple Python code here. I'm importing a joblib. It is not required the JSON here, and if you see, named it as an handler. this naming convention of your Python code and your function name matters here. So you'll understand why I say matters here. So as usual, I'm just loading the train model, right? And then I'm predicting based on the request I'm getting. If you see, it looks like a typical traditional Lambda code, right? Even if you see in your AWS Lambda, in case if you use it, so we'll have this, we'll have an event and context, right? Whenever your Lambda is triggered, event is the variable where it holds your request data, right? So similarly, I'm getting from the event, I'm getting the data. We'll also see it what I mean this data here is. And now again, remember, we are not deploying a REST API using Flask or whatever it is. We are deploying in AWS Lambda using this Docker image. And in case if you want to expose this particular container as a REST API, then the traditional approach, you can assign API gateway to a Lambda. I already made a full-length video on AWS Lambdas. I'll keep that in description. Please watch it. You'll get some decent idea. Now, going back to your Docker file, AWS also provided a default runtimes which you can use it. If you see, I'm referring to a public ECR, or else you can also use your own runtimes like Python Buster, Python Slim that is available in Docker Hub. You can also use it. I'm just copying it and I'm running the requirement txt file, and this is something which is different compared to a traditional Flask methods, right? I'll also quickly show you a Docker file here. Let me zoom in. Did you see here where in case of a traditional Flask one, I say CMD, we are running Gunicorn, right? Where in case of AWS Lambda, if you want to deploy in AWS Lambda, this is how you need to do. This is your Python code name. Did you see Lambda underscore function dot your function name, right? So you should write your logic accordingly. In case if you have a complex data pre-processing or large data pre-processing steps, so how you need to do is in this handler code, you need to call your data pre-processing logic, and then you write a separate function or you write a separate Python code for a data pre-processing, call that here, and then you do a prediction after data pre-processing, right? It's just a normal typical Python coding, the practice that we follow, right? Now we'll build it. Okay, before we build it, the another thing which we need to do is, so once we build a Docker image, we have to push those images into a registry where it hosts your, or it will keep your Docker images, right? So we have a Docker Hub. I already made a video on that. I'll also keep that in description. So when you are using AWS specific native, we have ECR, which means Elastic Container Registry. So you can create a repository here. You can give any name. I already created one. It's pretty simple. Give some meaningful name here and say create repository. As I said, I already created one with Teja with data underscore ML. So if you see, there's nothing here. So first we have to build an image, right? Based on where's our Docker file? Based on this. Let's do that quickly. So first what we need to do is we need to log into our ECR. So for that, what we need to do is we need to create an access key and secret key, configure it in your local system, and then you might be wondering from where I'm getting this, right? You can get those details here. So once you open any of your repository, click on view post, it will give you the details. How can you log in or connect to your ECR, how to build it, tag it, and push it. So if you see here, we have a Docker, but we are not limited to the Docker. In my case, I'm using Podman desktop. It is an alternate version or alternate tool for a Docker. So in my case, as I said, I'm using Podman. Instead, wherever you see Docker, you'd replace with the Podman. Yes, did you see here? Here instead of Docker I said podman. Let me run this command. But remember one thing, in real time you don't build your images in your local system, right? You'll build it uh, in the code pipeline or using Jenkins, whatnot, but definitely not in local systems, right? So, and one thing which I'm talking about is this x86 and ARM64, right? So here is where you mention it. When you're building your Docker image, you should mention what is your CPU architecture. There are many, but if you see, this is one x86-64. I'll also quickly show you. Yes, this one architecture, right? And where is this? Yeah, we'll see this now. Let me run this. So did you see it is pulling from the public ECR location with this the Python version, and it is copying. You can see this copying, and then it is running this. May take some time, right? So what I'll do is I'll pause the video. Yes, if you see, it is successfully built a Docker image, so you can see that come on, here the podman, right? As I said, this is an alternative for a Docker desktop. Did you see? It's built 56 seconds back. You can also, okay, may not see this. Once you run only you can see. Okay, let's not discuss that. So now what I need to do is I need to tag it, right? As I said, these steps you can see it here. Did you see? That's what I'm trying to do. Now I successfully tagged it. What next I need to do is I need to push this image from my local system to the ECR, right? Which you should be able to see it here. Oh, it's very fast. I never expected. Okay. So the size of this particular image is 398 MB, close to 400 MB you can say, right? Now, your Docker image is pushed into the ECR from your local machine. The next step is to deploy it, right? Now, here we need to select a container image, right? What architecture we choose here is x86, right? So now let's say ML IRS model. You can browse it from here. So this is where we pushed it, and you can have multiple versions all the time, right? Now I'm just selecting an image. So we need to select the default role here, and you can say create function. Rest you have all the same luxuries what you have for your typical AWS Lambda, but if you see here, you don't see layers here because we don't need it. Everything will be in our container, right? Now, you see, it is actually deploying your container in a Lambda. Meanwhile, let's go to your test. We can build our sample data here. So, as you know here, in the event, it is expecting under a data. So, let's say data here. Also, we need a sample data. We'll just try to copy it from here. Right. So now we are good to trigger. Test it. You may get timed out error. I'm expecting a timed out error. Let's see. Yes, as usual. So it's a 3 seconds. Let's go to the configuration. Quickly make it 1 minute. It won't take 1 minute, but yes, it is updating your function. Did you see? So we'll wait for it. That's why the test button is disabled here. Now it's enabled. Let's click on test. Come on, I'm waiting for the results. As a typical machine learning model, it will need to load your model, get into the RAM, and then test it. and then predict it, right? Yes, did you see like it reached a container, right? It says there's something wrong with the data which we are passing. That's nice. Let's see if this works. So yeah, let's try to remove this double quotations. Come on. Yes. What happened? Yeah. So now let's test this. Oh yeah, now it worked, right? So my bad, actually I sent it as a double quotation, so it will take as a string, rather it is expecting as a list, right? If you see, actually there are different types of uh, iris flowers. This is one of the type uh, which I'm looking for it. I just wanted to show you, maybe I can show you here itself. When where is my Visual Studio? Oh, here it is. Let me, yes, did you see it? This is what I think it got predicted, right? Yes. So now you can just uh, try entering data. We'll see if we get any other prediction. It's the same. I don't know. OS color. I don't know. It is. I just wanted to show you a different results. That's fine. That's fine. But you understand, right? So we deployed a simple Docker image where we deployed a machine learning model on it, right? And another thing which I want to show is I'll just try to create one more Lambda, right? Maybe with ARM, right? Okay, ML ARM, right? We all know the Docker image which we build is for x86 64-bit architecture, right? Now let me select ARM and see what we'll get. As I said, this CPU architecture is quite uh, important to select because, as I said, for long running applications and large scale application, in terms of cost, it definitely makes lots of sense, right? So, as usual, increase that. We don't need to increase it. We'll get an error, anyways. Let's go to the test. Test this. Did you see? It says invalid entry point, right? But ideally, you may get a different error. You can say invalid runtime, something like that, right? Did you see it's get error frog, execution format error? But the same container we are able to execute with the x86 64-bit architecture CPU, right? Yeah. Oh yeah, you can see runtime. Right, whenever you find this particular runtime error, which means you selected a wrong CPU architecture. Hope you like this. So now we'll see, how we can deploy an existing Flask container in AWS Lambda containers with few workarounds. So before we see how we can deploy a Flask application in a Lambda containers, so I want to discuss few points here. So the first point is deploying a Flask application Lambda container is a bad idea, right? So whatever we seen just before, we are not deploying a Flask application. We are deploying a Python code in a container, and I mean in the Lambda container. That is fine. But if you have Flask application and you want to deploy it in Lambda containers, it's a bad idea. Also, it's not that straightforward to deploy a Flask container, right? Or the Flask Docker image in a Lambda container. So we have to install a package called AWS Lambda adapter. So this acts as a proxy between your Lambda container and our Flask application, right? So technically, it is this particular AWS Lambda adapter is built on the Rust library, as I said, that allows developer to run a web application on AWS Lambda. It also supports the variety, the web frameworks and languages that includes Express, Next, Flash, which we are going to see now, Spring Boot, Laravel, right? As I said, this is a one point or one stop library where in case if you want to deploy any web-based applications in your Lambda containers, then this is a go-to package. But as I said again, I'm saying it again, it's not a right approach to deploy a Flask application or a Flask containers, technically not application, Flask containers in a Lambda containers, right? So as I said, this AWS Lambda adapter, right, it works as a proxy between your web application and your case a Flask, the Lambda runtime environment. So whenever the request is made to your Flask application or a web application, the adapter forwards it to the Lambda function. The Lambda function then executes this particular, the web application or Flask code and returns adapt to the adapter, whatever the response you get from the web application code that gives a response to the adapter, then adapter will in turns response back to you. So complicated. And yes, so now we'll see how we can deploy it. So before that, I would like to see, we know this is a simple Flask application, right? So we have this particular method that runs your app, right? But when you want to deploy this, in your Lambda container, you should remove this and it should look something like this, right? Did you see we don't have underscore name underscore equal to main, right? This should not be there. And again, it's not that straightforward, as I said, because one thing is if you already have a Flask application which is in a container, so you have to rebuild your image because you need to remove this and rebuild your Docker image, push it to a repository, and then deploy in a container. If it is a simple, it is fine. In case if it is really complicated things, then it's definitely not a right choice. I'm stressing so many times. Okay, so now obviously we need to build an image and push it to our repository. So first let me connect to AWS. I think I already connected. It's running. Yes, the login successful, and now I'm building a Docker image. So if you see, these are the files I have, Docker file, lab.py I just shown, and this test.py Lambda function that is not required, I just kept for my testing. Now I'm just building an image. Hope if you see it is copying this particular extension. I'll also show you the Docker file, how it looks big. Yes, did you see I'm copying this particular AWS Lambda adapter into my Docker image, and which is in the public ECR itself. I think it is built from AWS Guru. So yes, I'm referring to a public ECR image and copying it to my Docker image. It is successful. We know the steps, we already seen it like few minutes back. Now what is this? This is a Flask 1, is it? Yes. Let me run. Now we need to tag it. Let me clear this. Yes. And then we need to push it, right? Before pushing it, we'll see if there is any, no, there is no image here. We'll see how long it will take to push an image. Oh, let me refresh this. Oh yeah, did you see now we got an image here? So now to deploy this ECR image in your Lambda container, the same steps that we have seen before. So let's do it again. I'm opening a Lambda console. Let it get open. Oh yeah, it's a container image. FL Flask app. I have only one registry and one image in it. So what we selected when we are building an image is which ARM, I mean x86, right? This is the right one. Sorry. We can use the existing role and let's say create function. Yeah, it is creating a function. Let's see how it goes. Yes. So now let's test this. I'm not sure how it goes. Yes, it worked. Did you see? It says the server is GUnicorn. Yes, it's GUnicorn. We are running GUnicorn. And yeah, we got the status code 200, which is success, obviously. Where is the message? Yes. Did you see the body is hello world, right? That's what we are trying to respond, right? And it says is this base 64 encoded? It's not. But again, as I said, right, like if you see there are so many things which we really don't need it, and in case if I really want to expose this as a REST API, again this particular Lambda I need to point it to the API gateway and bypass from API gate to Lambda. There's so much complicated things. As I said, again, let's not, in case if you have any real applications that is already built on Flask and which is already in your container, I mean Docker image, let's not use Lambda containers. You can better choose ECS or EKS, either one of this option. So yes, that's what I wanted to cover. Hope you enjoyed this video. Stay tuned. There are a few more interesting that's gonna come. Thank you.